All right, we are live. Hello, everybody. Welcome to another day in RPG game development. And today we're gonna pick up right where we left off. Hi. This is the Blizzard Snow Emitter class, and what it's going to do is emit a bunch of little snow particles for the Blizzard ability that we're implementing today for monsters. Yes. So let's get started with that. The emit function is what gets called every time this frequency or the timer hits 0. So basically we just write in here what's supposed to happen every time this emitter emits, I guess. So as you can see, that's the code for what the emitter does. And we basically implement the rest. Plain and simple. So in here, what we're going to do is we have provided a position and a scale range, and I guess we need a radius for this Blizzard Snow Emitter. So we're going to add that too. And we're just going to make that work. Now, why don't I just make this whole thing a custom name called a range, right? I think that's fair. We can say using range equals one of these. Wouldn't it be cool if we just made a range class or like template? I feel like that would be cool. We have to be careful though, because there is already a standard ranges class that exists. So yeah, there is that. But this might be nice to have eventually. I don't know. Anyway, yeah, we just apply a range, I guess. So in the emitter function, we're going to have a bunch of particles come out based on this position and radius and a scale range. So we're going to need the Adventures in Listoria class to access the game world, because we need to be able to add an effect to the world. So include this, which gives us access to game. We have to include game to have access to the game pointer. And then in here, we can call game add effect. I don't know what I just did there, but that's not right. And in add effect, we provide a unique pointer with whatever effect we're interested in. So we have a generic effect, so that's what we're going to do. Standard make unique effect. And a generic effect you supply with a position, a lifetime, an image file, and you can supply some other parameters. So we're going to probably supply a speed so that it is moving naturally. Maybe a rotation and rotation speed if we're thinking of doing like a snowflake or something. But for now we're just doing little like snowballs. So for the snowballs, I think we're just going to use the circle image. Oops. I want to open an Explorer window, thank you. So let's just take a look at what that asset is called. Now I did provide an image file name here, so I guess we'll just pass that along. I still want to know what that is though. So in here, we're looking for circle. So there's circle.png, there's circle outline.png. We probably want circle, and it's just... It looks like it's just a 3x3 little cross, which I guess is fine for our purposes. I think circle outline adds an outline to it. Let's just have a quick peek. Maybe we can use that one. I hope everyone's doing great today. It is a Monday, so start of a brand new week. And this weekend is Valentine's Day. I'm super excited. So this is just a circle outline. It's just not filled in. I don't know if that's what we want. It probably is what we want. Or in the sense of maybe we draw the circle and the circle outline together. I have to think about that. It can go either way. Let's see. For now, I'll just do a circle. Oops, I don't know what just happened. So anyways, for the effect constructor, we're going to have the position. So the position is going to be randomly chosen based on the radius, right? We're just going to choose a random position within a circle. So we'll define a random distance from the center. Const float distance will be util random range from 0 to the radius. Oh, and we have to store these parameters too, right? So the Blizzard Snow Emitter is going to have some parameters that we're going to store away. And these are supposed to be public. Or rather, let me see, do they have to be public? The constructor definitely does. I don't think emit has to be. Emit can be private, or at least protected. It should only be accessible from any classes that inherit from it. And then privately, we should have the radius for sure, the position, the scale range. Honestly, yeah, all these that we supplied here, and the image file name. Although I guess the image file name, yeah, like all these need to be stored. Like so. And then filled in here. So pause set to pause. Image file name. Set to image file name. Radius to radius. And scale range to scale range. Okay. So that should be good, I hope. Image file name is not a non-static data member. But it is. I defined them down here, didn't I? I feel like I have some kind of weird syntax going on here that I need to fix. Constructor looks fine. Something's not right. Like this brace is not matching up somehow to this brace. It's matching up to here, so I missed... Oh. Oh, I haven't closed this, so everything's wrong right now, right? There we go. Okay, yeah. That's what I did wrong. I just forgot to close out that curly brace there. So now we can set pause to pause. Lifetime. The lifetime should be some small amount until it hits the ground. So what I was actually thinking was these effects would actually start in the air. I don't know if these have a Z or not. They do have a Z, and I assume if they have a Z, then the draw function draws them correctly. Okay, yeah, so they do get a shadow. So that's good that the Z actually respects the being in the mid-air mechanic. So what I'm going to do is I'm going to make these effects start with a certain Z, and they're going to fall down. I don't know if I have an effect that is just called like a fall down effect or something. Oh, there it is. Falling debris might work. Let me see what falling debris does. It has a gravity and the speed dot y. Oh, so it just moves in 2 dimensions. It doesn't account for the z. So what I'm really looking for is something, some kind of like falling effect. So that doesn't really exist yet. So we might actually add that ourselves. But the idea is the effect starts with a certain z value, and then it increases over time based on some gravity constant, just like the other one, but it actually hits the ground and disappears, so that the lifetime is actually dependent on when it reaches the ground. Also, hello, the Grand Shark. Welcome to the stream. Good to see you again. Hope your day is going well. So yes, I think that's what we're going to implement. So we're going to make a new effect called fall effect.h. And the fall effect is going to inherit from the effect class. As in, it's going to have a position, it'll have a lifetime, it'll have all these things, which it's going to pass on to here, but instead, it's going to have a z value to indicate its height. So we're going to add in a const float z, and the z value will be stored inside of the z parameter, which is also part of an effect. So it has to go in the effects z, not this class's z. So we're going to say this z equals z, because we can't set it via constructor directly. And then when we update, we have a gravity constant here. Although I think I want it to be configurable per fall effect. Let me rename this to fall effect. And it's going to be z minus equals whatever gravity is. So we're going to define gravity in here. Const float gravity, comma, and then we're going to set that. I'm going to put it down here. I've been liking the more traditional convention of keeping all public members of a class at the top, putting all private members of class at the bottom. We do this because when we open up a header, we're trying to see how we interface with that object. If you have private members at the top, or a mix of private and protected members plus public members, it's unclear how you would use this object. For example, let's say I want to know how to use the player object, right? So if I'm going here, I can see that all my public functions are right here, so I already know exactly what functions I can use as a player. You have all the getters here, you have a couple of checks, you have a couple of sets. Like, you can see the whole public API for a player at the top, and then all the implementation details, all the tiny variables that don't matter to us when we want to know what a player does is down here. So that is ideal. It's going. Currently planning out a script I want to write today. Hope you're doing well. Yes, yes. It is a Monday, so we're kicking off the week to a great start. And it's Siveth. Hello, been a while. Yeah, Sig is perfectly fine with me, or Amy, whichever you prefer. I don't mind either. But yes, welcome to the stream. Good to see you. Okay, so we're going to be storing gravity. I don't want to make it all caps, so I'm going to make it lowercase. And yeah, it's just going to subtract, and then if z is less than or equal to 0, we're going to make it fade out. So we actually have a fade out like variable right here. So what we're going to do to force this fade out value and respect it is to set the lifetime equal to 0, and this effectively makes it does the fade out part. And what we do is we initially set the lifetime, so we don't include as a parameter here. We set the lifetime to infinity, and then it gets set once it hits the ground. So lifetime is infinity. And we're just going to write a little comment at the top here, what this class does and why we use it. This class is used when you want an effect to start in midair and fall down. It disappears upon hitting the ground. Okay, that way, if we ever want to know what the fall effect does, we'll get in a little tooltip. The Dragon Nest Goat. Oh my god, please don't say that. God. You have to say at least once every year, don't you? Somebody has to. Sillies. It's 2026, by the way, and we're still talking about Dragon Nest. Hello? Who are you? Okay, so gravity is getting set to gravity. Oops. And we're not gonna have this. Okay. And I think that's everything we realistically need. I don't expect anything else to be an issue here. I am going to say that this is a const ref though, because passing in a copy of a string is slightly expensive. Overall, it's not going to affect anything realistically. But let's say we're creating a bunch of this effect, right? Effects are more prone to being thrown into a loop and constantly spawned. Then in that case, we want to make sure that we're not copying a string over and over, because that's literally what we're telling the compiler to do without sending as a reference. So I should also fix that for falling debris. This is technically a typo, and I would argue this is a pretty big typo. We want to pass by reference, because it's not important to copy it there, it's important to pass it on there. And you see I do it here in effect, so that's good. I think I just forgot to do it on the outside as well. So anyways, this is what the fall effect looks like. We can now go back to the Blizzard emitter, and instead of creating a new effect, let's now create a new fall effect. So we're not implementing it in here. Like, we're not defining the behavior by grabbing this unique pointer and making all the behaviors ourselves. Now we created a class that does the behavior for us, and we're just going to use that class now. And from now on, if we ever need that behavior, we have it all wrapped up in a neat little object. So that's great. So that is the fall effect, and we're just going to follow its parameters now. So the Z value, we're going to choose a random value. I don't think it matters right now, really. We're just going to choose something. So again, I can do, let's say they can start up to 100 pixels in the air. Let's just try something like that for now. I think that's a good value. Starting Z, let's say, is a random range between, I'm just going to say 0 to, or not 0, maybe we want to always just start in the air, but it doesn't have to start very high in the air. Maybe like 30 to 100. Anywhere in there I think is good. Although, let's say we spawn the blizzard, like we see the effect. It would be kind of weird if there's just some particles missing near the ground already, right? So maybe if we create enough particles, we just have that entire range covered. I think it'll look more natural rather than having a giant gap at some range. So I think this makes the most sense. So that's going to be our starting Z. Now, as for the gravity is interesting because what I wanted to do is I kind of want to randomize that too, so that you get this effect of like some snow falls faster than others. It's usually based on the size, like the heavier it is, the faster it should fall, right? In theory, although that's not actually how gravity works. In reality, the things that are lighter tend to fall slower because of resistance, air resistance. It's not actually because gravity works lighter on lighter objects. You learn that in a physics class. But it's very deceptive, right? It's just the effect, the result we end up with from how air resistance works. So we're just going to choose a small range of gravity here. I am going to make it random. I'm not really going to base it on the scale of the snow. So I don't really care too much about that right now. We're not really going for a realistic snowstorm. So yeah. Let's do that. Now, this effect is going to last for a while, so if all these snow bits fall, we're going to have to generate more. So this is like a constant generator of snow, right? That's why it's an emitter in the first place. It's going to generate more and more over time. So having all these in different spots, being generated at random locations, with random starting Z and gravity, will essentially give us the effect we are looking for. So I'm going to put starting gravity, or I'm not even going to say starting gravity. This is just going to be the gravity we use, right? And it's going to be a random value from 0 to whatever the max gravity we're interested in. I'm just going to say probably the slowest we want to go is maybe like 10 or something, because if we spawn at 100 and it has a fall speed of 10, it's going to take 10 seconds to fall, which is a very, very long time. But I will say this. When the blizzard ends, we are going to just loop through and destroy any snow particles ourselves. So we won't have to worry about any stray particles. At least we shouldn't. How are we going to do that, though? Because we don't have a way to identify these right now. So we will need a way to do that. As in, anything that the blizzard snow emitter spawns, it also has to be responsible for destroying, right? So that's an interesting point, is that it's almost like we need to keep track of what fall effects we spawn and then get rid of them ourselves. But the game is supposed to be responsible for that. So how would we handle this correctly? Normally, when the fall effect reaches the ground, it's supposed to set its lifetime to 0. But what about in the case where it doesn't? Are we going to make a list of every single effect we create and then set the lifetimes to 0 ourselves? I don't know. It's almost like I have to make another identifier specifically for these effects. So deep within the effect class, we might have to add in something to identify very specific... Oh, I've already done this before. Look at this. So set type. We have an effect type enum, and we can add to it. So I've already prepared for something like this. Excellent. So what I'm going to do is I'm going to add the blizzard snow to our effect types. See, this is what I mean by complex projects. You need to kind of look at everything you've built before, because it's very likely you've already tried to solve such a problem you've had before, and then you just didn't realize that you've had the solution there kind of the whole time, so you don't end up like reinventing the wheels you made a million times over. So yeah, we're gonna add an effect type for blizzard snow, and then what we're gonna have to do is we're gonna have to supply that inside of here. So we need an optional effect type that we can then write in here based on how we want to identify it. So I'm gonna throw it in at the very end here. Const effect type type, and by default it's going to be set to none. Now it is an enum class, so we are forced to type out effect type : none, which is fine. And then Or we can do using enum if we really want to, but I don't think we need to do that here. And then we pass in the type presumably, or we have to set it ourselves. So we would do this type. Oh, we have a set type function. So we would do that right here, where we would just call set type and then provide the type that we supplied in the constructor like so, if we needed that, right? I think that's how I want to use the system. That way it's non-intrusive to any currently working effect code, but then it's also useful pretty much anywhere I actually need it. It's an optional tagging system for all of our effects in the game. Now we have a way to identify them, and so we can make a method to kill them off when the time is up. Excellent. So that's what we're going to do. So now we're back in here to the fall effect. We're going to be specifying a gravity value, and that's going to be right there. They could fall really fast. I don't want it to be 100 though, maybe like anywhere from 10 to 40 I think would be a very good range. That means it takes approximately 2.5 seconds maximum for them, or minimum for them to fall down, which I think is a good amount, assuming they start from 100. So I think that's a great fall speed to be at. Oh, let me turn on... Actually, yeah, let me turn this on. Just so we have something running in the background, little chill music. Okay. Upper level is going to be based on the upper level of this snow emitter, although I don't think this matters here. Let me think if it would. It would only matter for determining what the order of stuff gets drawn in, and I really don't think we have much there. But let me see here. I want to say it doesn't matter. We can just say it's not on the upper level, but it really doesn't matter. Yeah, I guess we could pass it in. You never know, right? We might actually use it for something in the future. But it's needed for effect, so upper level. We're just gonna go ahead and include that. Full upper level, and then we can specify that in here. And then we got the size parameter. So we want the size parameter to be within this random scale range. So we want them to be even. So we'll select a random amount. Scale is going to be a random number that is between the low end of the scale range. Scale range dot first. And the high end of the scale range. So scale range dot second. And that's gonna be both for the X and the Y. So we'll again do a scalar multiplied by a 1, 1 vector. That is an easy way to type out the same parameter for both the X and the Y vector. And then we have the fade out. I want the fade out to be pretty nice. So again, we'll go with 0.5 second, at least for the time being. And then we have a speed. So the speed is actually how it's gonna move. I do want them to move kind of all in the same direction. I guess I'm just going to go with from right to left. So we'll say... This is a little tricky, because if I do say move to the left, then I also want to offset the position by a certain amount, because I know they're going to end up moving to the left, and the position we originally specified is the quote-unquote range of the blizzard, so I don't really want the snow effects to particles to end up outside of it. That doesn't really make sense. So if I'm going to do a speed, then I need that speed parameter to adjust the position parameter as well. So let's say, for example, we're moving at a speed of minus 5 pixels per second, right? Minus 5. If the snow is going to fall for like, if it's going to exist for 3 seconds, that means it's going to have moved 15 pixels to the left by the end of that. And if it's moving 15 pixels to the left, then I need to add 15 pixels to its spawn position, regardless of where it wants to spawn. So there is that dilemma. Do I want to account for that? Sure, why not, right? In this case, we're going to first have to define some kind of X speed. So I'm going to do, for my example, I will do the minus 5 pixels. I think that's a very slow amount. And we're going to try doing that. So next, now that I know the X speed, I have to determine how long it's going to take for this snow that I'm spawning to fall to the ground. And we know that by taking the starting Z divided by gravity, because the faster the gravity, the faster it's going to fall down. So that's how much time it will take. So time to fall will be set equal to whatever the starting Z is divided by the gravity. So let's say the starting Z was 100 and the gravity was 10. That means it would take 10 seconds, because it's going to fall 10 each time, to hit the ground. So this is the time to fall in seconds. So now that we know the time to fall in seconds, we can multiply that by the X speed to determine how far to the right we have to start it spawned. So now we're going to add a new vector that is offset by X speed multiplied by the time to fall. We can keep the Y set because we're only going to move to the left, and then that makes the speed equal to X speed, comma, 0 as a vector. Next, we have the color of the snow, which I think I will randomize slightly. So what I would like to see is, if I open up GIMP here, I think what I would like to see is, starting from this like bluish color, any range from this bluish color all the way to white. So anything like that. And I think the best way to do that is we just we kind of do a linear interpolation from 0 to 1 of the ranges of these values. So from 104 to 255, from 215 to 255, and from 239 to 255, we do a range interpolation of those to get a value that scales up from this bluish to this white. So like, for example, if it selected a value in the middle, the red might be here, the green might be there, and the blue might be there. So it kind of stays this bluish color. It's just everything gets pushed towards the white color we're looking for. So we're going to choose a random value. This is the color interpolation value, and it's just going to be from 0 to 1. So we'll use util random from 0 to 1. And then based on this, we're going to multiply it by well, I do have a lerp function, and I should be using that, honestly. Where'd GIMP go? Oh, I closed the window. So yeah, we can use these values as a starting point for the lerps, and then 255 as the ending value. So for our color here, now that we have a color interpolation value, which would be your T in a lerp formula, we're going to do util lerp, but let's do this first. So it's going to be util lerp. So you provide 3 values here. You first provide value 1. In this case, value 1 is going to be for our red. So 104 to 255, and it's going to be from, or the T is going to be the color interpolation, and all these should be floats, by the way. Like, this is templated, so you should be able to determine that from this, I think. Yeah, it auto templates that for us, so that's excellent. So that's 1, or that's for red. And in fact, we can go one step further, and we can say the base color. So the base color is going to be 104, 215, 239. 104, 215, 239. And then we come back over here, and instead of doing all this, we just say baseColor.R to 255. We make sure we cast that to a float, of course. Now, if it's a float, we're going to end up with the float version of the color constructor, which is not actually what we want. We want the uint 8t version. And the reason why is because it's going to be a value from 0 to 255, so we're going to need to cast it to that so that actually uses it. There is a float version of the color pixel constructor, but it's very niche because you have to supply floating point values to begin with, which we could do. There's nothing really wrong with that, but in this case, if we send in floats here, it's gonna be like red is 255. Well, what does that mean? It's gonna be way over 1.0, which is wrong. It's supposed to be between 0 and 1 if we use the float version of the constructor. So here we have red, green, and blue. From whatever values we have to 255. So we're always going to end up in this range where it's always going to be from this light bluish color to white, but it'll never be like accidentally red. Like if we just did random for all these from these ranges, it could pick this, and now it's like a pink color. Although that's not a terrible idea. That would be kind of interesting to have snow that's like kind of light blue, but also red at the same time. It's an interesting idea to play with, but I also don't think it has too much merit here. So then we have the alpha. Now, do we want to play with the alpha is the question. I'd say maybe a little bit. So let's do a small random value like alpha, and we'll make the alpha be... We are going to have to cast that, so we will. It'll be uint 8t, and let's do from 0 to, well, not 0, but maybe like 96 to 255, I think would be great. Good morning, Amy. I got us more Girl Scout, no, more Girl Scout cookies. We're gonna be so sugared up. Stop. Yes, hi Plasticky, welcome to the stream. Good to see you. I hope your day is going well. No, I want more. You want more. Girl, calm down. God. Yeah. Anyway, upper level. We need to provide that. It's complaining that we don't have a initializer for upper level. Heart. Heart. Alright. Okay, so that should complete our color. Oh, and the alpha. Right. So, random alpha. For a little blizzard snow. Alright, next up is the rotation. Now, it's a circle, so realistically the rotation can't matter that much, but they are in pixels, so rotating the pixels might make it kind of funny. Might as well just randomize it. Let's randomize it. Anywhere between, let's just say, it's supposed to be in radians, so we would convert it, right? So we would do util... If we were to do degrees, which I usually like to do, then we'll do util degrees to radians. And we'll do util random range between 0 and 360 degrees. And we deg to rad it. Then we have the rotation speed. I don't think we'll do much. If we're gonna do any, it's gonna be very small. So maybe like a random amount between -1 and 1.0. And then next we have whether or not we're doing additive blending. I think it'd be great to do additive blending for this. And then finally the effect type. So this is where we supply that we're specifically going to provide the snow effect type, because this is a blizzard snow emitter. So naturally we're expecting this to emit blizzard snow effects. So effect type blizzard snow. So with that, the add effect call should be complete. So we can close that out. And standard make unique is not happy. So nothing matches the argument list. So what do we do wrong there? We provided a VF2D. We provided a Z. We provided a gravity. We provided a string for the image file name. We provided a boolean for the upper level. We provided a VF2D size, a floating point fade out. This is unspecified, so this is a VF2D, this is a pixel, and what else? There's an extra comma there for no reason. So now it is happy. Okay. So that's what's going to emit at all times. So I think what we should do is we're actually going to call Blizzard Snow Emitter emit quite a few times on our own just to get it started, right? I think that would be a great idea. I don't know if... Yeah, I guess the emit function should be public then. So we're going to remove the protected line there and just make it public. Vicious Guy 3758, hello, and welcome to the stream. So now that we have the snow emitter, let's go back to the Blizzard cast. So we're gonna go to the monster class, or the monster ability class. I don't know if we actually started on that yet, but let's take a look. Yeah, there's nothing there for that yet, so we're gonna be adding that now. So this is the next ability. It's not actually for the fire mage, it's for the frost mage. We're just implementing all of the monster abilities today. At least we're gonna start going through them, because that is our next objective for our game, is making all these casters. So yes. So yeah, all these like values that we are hard coding right now, technically they should go in here. That would be the best place for them. So maybe we'll redesign that later. That's just kind of an oversight on our part. If we want to, we can create that now, but I kind of want to just get the Blizzard spell at least in the game, and then we'll look at that later. But then I also see here, we also have all of our configs set up for this, so maybe we're not going to be able to avoid that in the first place. So yeah, we might just want to implement this now. So what we're going to have to do is work on the setting up the Frost Mage just in the game real quick. So it's called Skeleton Frost Mage. So let's go ahead and first make a placeholder graphic for it. I don't have to do anything special really. I'm just going to reuse this. We'll go ahead and recolor it real quick. Oh, let's unindex it. That'd be nice. And I'll just do this for now. Then we'll index it to our palette and export as the Skeleton Frost Mage. So again, we don't have actual graphics for our new monsters yet, but that's okay. We're just using placeholders. Perfectly fine in our case. So now we're gonna go to our monsters database, and let's go ahead and add a new entry. or the Skeleton Frost Mage and input its stats. Okay. So Skeleton Frost Mage. Let's look at... It has 650 health. It has an attack of 41. Which means that'll probably be the same as our collision damage here. It has a movement speed of 80%, a size of 90%, XP value of 49. And then it has two abilities, one called Blizzard. And one called Freeze Ground. Oh, so one thing I wanted to add was that for any monsters with abilities, if they have abilities, we want to check against the list of abilities and say, hey, we specified an ability that doesn't exist. That makes no sense, right? That way we're not looking up something and crashing in the middle of the game. We can do this at runtime. A runtime check. So that'll be under monster data, under initialize monster data. So let's go there real quick. So right here, where we're reading in all the... let me see. There should be one for abilities. Here it is, for abilities. So here you can see we immediately just place back the abilities, but we should definitely verify that the ability exists in the first place. Otherwise, we're gonna run into trouble later. So let's go ahead and do that now that we can. These abilities are static, so we should be able to just say monster ability. Well, we're gonna have to include it. So we're gonna include monster ability.h, and then down here we're gonna say if monster ability : spells dot and then this is a map, so we can do contains, and we're just looking for the string name. So we're looking for the ability, or the key. The key is the ability name, so we can do that here. So we're actually going to error out if it doesn't contain a key. That way we know for sure that we have done something incredibly wrong here. So let's do a standard format and just say warning. Monster ability does not exist. Failed to add ability to monster, and then provide the monster's name. So this would be key, comma, and our monster name. Okay. So we'll produce an error there. So technically, if I run the game right now, we don't actually have those new spells created yet. So the fact that I'm adding this ability called Blizzard and Freeze Ground to the Skeleton Frost Mage's abilities list is going to cause an error. So we will test if the error actually works now that we've added that, as that's a way to prevent ourselves from shooting ourselves in the foot by adding stuff that doesn't exist and having to wait until the game actually casts the ability by the monster to find out we did something wrong. So right now, I'm actually just going to add the Blizzard ability here as a placeholder. I'm not even going to do any of this yet, but I'm going to purposely keep out Freeze Ground, at least for a moment, so we can test that real quick. So going back over here, we're also going to run... Now, this is interesting. All the mages, I believe, behave the same in terms of, like, movement. So, yeah. We can actually use the Skeleton Fire Mage strategy for all three mages, because all three of them will do the same movement behavior. So, yeah, we don't need a separate strategy for those. So leaving the strategy as Skeleton Fire Mage is actually the correct play here. Everything else can stay the same for the time being. And so the next thing we have to do is this image needs to be included in our asset pack. So I'm going to delete the current asset pack so it can be regenerated with the new graphics. I'm now going to go over here, and under Skeleton Fire Mage, we'll have to put all the Blizzard related stuff in there. So we'll get to that momentarily. But let's go ahead and first build our game. We're going to go back to the normal project here instead of the unit testing project. And we're going to try and build our game. And then we're just going to run it. And what it should do is it should complain, or we get errors because we did something wrong. Cannot open file, include friendly tag. So this is old. This should be friendly type. I wonder if there's a... It appears there's a couple of these. Oh, it's all iBullet. Alright, try it now. So that was just left over from, I think, the previous iteration of this. There's another one in effect.h. Okay. Yeah, because I renamed it, but then I didn't go through and fix all the headers. So, all the header includes. So, with this out of the way, we technically have the framework for the Blizzard ability. We have the snow emitter. We're going to spawn a damaging circle. We don't actually have the effect implemented yet, so that would be our next step, right? And I think I started a Blizzard effect, I just haven't worked on it yet. So yes, Blizzard.h contains our Blizzard effect where we're going to do all this. So we were working... Oh, this is not going to compile, so we're actually going to error out here in a minute. Oh, we have another friendly tag.h that we left, so we can fix that while we're at it. But yes, now let's go back to Blizzard.h and implement this. So we were at this part where we were still like figuring out, okay, how are we going to implement the effect, right? So, right here we're going to be hurting any units within that are inside, depending on if we're friendly or not. If we're a friendly bullet, hit only monsters. If we're a non-friendly bullet, hit only players. IntelliSense doesn't want to catch up. Oh, it trolled me. It did it right when I was about to navigate to it. So, come on. So, it needs a position. The position will be pause, of course. The radius. The amount of damage done. Whether or not it's on the upper level. The Z value. Now the Blizzard itself has the upper level flag, so calling on upper level is the same thing, okay? The Z value. Kraton, thank you for the follow. Welcome to the stream. Alright, Z value. I guess we just supply our Z here. And then the hurt targets. So this is going to depend on the friendly flag. So I'm just going to do a ternary operator here. If we're friendly, then the hurt type should be player. Otherwise it'll be monster. I find it interesting that they're 1 and 2. Anyway, so yes. In this case, the hurt type is monster. Otherwise, the hurt type is player. And notice that it's actually complaining that friendly is undefined because we have not defined that down here. So that's what we were working on last time. What we spent all of that previous stream doing was creating a new friendly type just to handle storing this information. So we're going to put that now in here. Friendly, stored in friendly. So hurtful. Right? Okay. And that should be it for the hurt function itself. So the tick timer, the tick rate, let's see here. The blizzard will have a lifetime. The lifetime will be handled by the parent effect class. So now we just have to generate the emitter. So this blizzard comes with its own emitter. So we're just gonna add that now that we've made it. So blizzard, I have to include it. It's a blizzard snow emitter. Now this is interesting because blizzard.h includes adventures in Lestoria.h. I wonder if adventures in Lestoria.h includes effect.h. I feel like it does. Okay, and if it includes effect.h, I'm now scared that effect.h... Well, okay, so nothing needs this other than here, right? But if I include it here, this dependency... Okay, as long as blizzard, nothing needs blizzard.h, which monster ability will need blizzard.h. So am I creating a circular header reference by doing this? Because I'm going to include blizzard.h here. We'll have to see. If we get strange errors, we're going to have to actually not inline this, because right now we have inlined it, so this is just a header. Can you show a quick demo? I just got here. Yeah, I can show a quick demo in a minute here. We're actually about to build it. Blizzard snow emitter. Snow. I'm just gonna call it snow, and we don't have to actually do anything with it yet. But technically, we should be building now. But like I said, I think the includes are gonna get funky here, because yeah. So emitter is an undeclared identifier here, so I would have to include emitter. And the moment I include emitter, let's see here. Yeah, this is about to get real funky, isn't it? So this is what I was talking about earlier, how if we define circular headers, we're gonna start getting weird stuff happening. So that's what's happening here. So the way you fix this normally is, it means your dependencies are... You basically didn't design your dependencies correctly, so you have to split up stuff. You have too much stuff in one header. This is by design. So this blizzard snow emitter needs to have its implementation and its definitions separated. I was trying to do a shortcut here, but it doesn't quite work here, because this blizzard emitter needs the emitter class relies on the monster class, and the monster class relies on blizzard. Pragma once doesn't fix this, because what's going to happen, since these are inlined, right? You can imagine what inline does is the compiler essentially says, okay, I'm going to copy paste this somewhere. So now you have it copy pasted in, let's say, this file, right? And then if you think of it as like a single giant header file, well, now if you include it ever again, you're going to have a multiple definition error. So what if this is needed in another location? Now it's confused because it's referencing the one that's from earlier or the one later. The compiler is going to have multiple definitions of it, which is the problem here. So the only way to fix this is to separate your not cascading, it's like a circular dependency loop. Your headers are circularly including themselves, and the compiler keeps including the same headers over and over until it just gives up. And that's when you get weird errors. And when you get the weird errors and you're like, well, my code's correct, that's when you realize that it's probably circular dependencies. So again, the way to fix this is we have to separate implementation from definition. So this is going to be the blizzard snow emitter getting its own CPP file instead. Pragma once only saves you from including the same header file in the same file. So for example, if fallEffect.h includes emitter.h and I include emitter.h here again, it's essentially not going to do it a second time. It's like doing those define like doing those like define macros, like the not defines and defines. It's basically, that's all Pragma Once essentially does, and it does it automatically. And also, it's based on file name and file location, so even then, sometimes Pragma Once has its faults too, but it's very obscure, and you're usually not going to run into it as a normal developer. But yes, hello Kraton. Welcome to the stream. Good to hear from you. Yes, so what we're going to do is, I usually just copy paste, and then we work from there. So, for this class Blizzard Snow Emitter, we're going to take out all this. We're only going to include Blizzard Snow Emitter.h because anything it depends on will be in there. And see, this is the key here, is that one of these includes is having to include itself, like include Blizzard Snow Emitter somewhere else. So the key is we're going to be eliminating some of these by making this only have non-inline functions. So what we're going to do here is only include, let's see here, we can't do override in here. I think we can do final still. We're not going to include anything about the implementation, so it's just going to look like that. And then we have these here. So now that we've done this, we can remove any includes that we needed before that we no longer need. So right now, VF2D is ambiguous, so that's interesting. I don't actually know why that pops up, but it's supposed to be OLC VF2D, so I'm gonna force that. I'm not actually sure why it does that. Range is not a type name, so that's the using. This in itself should be working. I think there's something else going on here that's weird. But because I only need VF2D, let me see here. Yeah, before I needed adventures in Listoria.h because I needed the game pointer. So now I'm gonna delete that, and I don't need this anymore. I just need OLC util underscore geometry 2D, which has the VF2D class. I think that makes this unambiguous now. Hopefully. Nope, it's still ambiguous for some reason. Thinking of it in translation units helps. The compiler's concerned with declarations being overwritten with other definitions and declarations, so once things are parsed out into translation units, Pragma Once or using if-def guards stops more than one translation unit. I like that. That's actually a very good way to put it. Thank you. Variable range is not a type name. Well, it is because it's up here, but something else is going on here. So let's see what else we don't need now. So we don't need fall effect because fall effect is going to be included in the implementation now. And do we need emitter? We do need emitter because that's where iEmitter comes from. I don't know why range is still not a type name here. That might just be some kind of cascading error, or IntelliSense is not caught up. I'll leave this as is for now, and we'll come back to it. So now we're over here at implementation. This is going to be the constructor. So Blizzard Snow Emitter, Blizzard Snow Emitter. This is a virtual inline void, Blizzard Snow Emitter emit, override, final. I don't think we need virtual. We don't need inline and don't need override, I think. Or we don't need final. Hold on. Something's not right. Something... I messed up something. I know for sure we don't need that. I'm just gonna erase these. We're getting confused. So we definitely need util. So util.h. Let's see what else. So we're gonna need game again. That's what I was talking about earlier. And I can see my other file, the range thing went away. So it was definitely just IntelliSense catching up here. So it's gonna be include game. That I need to first include Adventures in Lestoria, which I think is going to include util on its own, so I'm going to get rid of this. And that's going to allow me to access the include game macro, which then lets me access that. And finally we need the fall effect, so again we'll include the fall effect. And that will take care of that. And I think we should be good now, but we had to separate that because there were header circular dependencies, at least from what I could tell. Blizzard Snow Emitter already has a body. Where did I... Oops. Get rid of this. That should not be there. And get rid of these as well. Okay. Just left over from earlier. I think I'm supposed to put... Huh. I could have sworn override and final were allowed here. So that's interesting. Anyways, I'll include it here then. It's supposed to be an overwritten function, but I also want it to be final. Now let me try a build. I imagine with 22 plus years of programming, you'd probably know better than me. Well, in one sense I do, but in one sense I don't really... Like you said, I don't really think of it in translation units, so to suddenly hear it like that is like, oh, yeah, that's kind of a cool way to think about it. Also, this is just wrong. This shouldn't even be here. Don't need a semicolon. Let's format this a little bit. Okay. That looks a little more sane. And then we have some narrowing conversions to do, that's fine. Probably this one, because this is a float, so that will be a narrowing conversion. So U into AT. I already did U into AT here, so that should be okay. There's alpha, which is already that. Have you tried Raylib? Yes. I've used Raylib before. It is a C library though, so I'm not using it for this project because this is a C++ project. Plus I'm using OLC Pixel Game Engine, which is kind of like a C++ version of Raylib. Being quite literal, it's just a library that lets you draw on the screen with some extra utility functions. Damn, creating a game by yourself. I know, right? It's hard, but it's fun. I just enjoy working on it. It's my own little fun game. Okay. What else? We have to convert... Let's see, line 59. Float to uint AT. Where are we doing that? Because I already checked. The colors were good. Cast, cast, cast. I feel like that's the only place I would have done that cast. So that's kind of weird. Conversion from float to uint AT requires a narrowing conversion. Unless this whole thing's a float, that shouldn't be possible. I do have integers in here. Maybe that's what it's complaining about. So let me change those to floats. Although I casted it to VF2D, so it should know I'm okay with this. Thanks for the follow, Deoxify, and welcome. I have no idea about this, but it's fun to watch. I work in Java, but no proper knowledge in C or C++. Ah, yeah. I've definitely used Java a lot in the past, so that was like my flavor of the month for language for, I would say, a good 6-7 years, at least. Had good times with that. Yeah, I'm a little stumped here. This is strange. It's saying conversion from float to uint AT requires a narrowing conversion. Yes, I'm aware of that. I'm unsure where the problem is here, unless... I'm trying to remember the distinction between using a curly brace versus a parenthesis. I think one is a literal cast. I think the other is a construction of an object, which I think might mean it's being considered a narrowing conversion, and why it might be causing problems. Yeah, I think that was the distinction, is using parentheses makes it be considered a cast, but if I'm constructing it, it wants to then convert it, and that's what I was complaining about, that narrowing conversion from trying to construct a U into a T from a float. Okay, so, which means I have to cast it inside of the U and AT, which is funny. Okay, so it needs to know what emitter is, so this is where the circular dependency would have come in, because I have to include emitter here, because it doesn't exist elsewhere, but I couldn't include it before because if I did that, I would have started a circular reference with the Blizzard Snow emitter from earlier, because it has emitter.h, and I included that inside of Blizzard as well. So I think we're good now. At least I hope. It gets a little confusing when so many things need dependencies of each other, and you're trying to manage all these header files and includes. So this is an action-adventure role-playing game. It's still saying emitter is an undeclared identifier, so that must mean I have another circular dependency. Maybe it's coming from Blizzard, because Blizzard itself uses inline functions, and that also includes the Blizzard Snow emitter, and this would include emitter, so this would depend on both. Yeah, so it would go include emitter, include Blizzard Snow emitter, which requires emitter. Yeah, that wouldn't work, would it? Okay, so I have to split up this one as well. It depends on it too, unfortunately. Okay, so let's go one step further and make a split here. So it's going to be blizzard.cpp. And for effects, I usually move them all into effect type.h. So let me open that. So originally I was looking at this and I'm like, oh, I'm going to put them in here, but then I decided not to because I'm like, I could inline them. But I remember last stream I even said, I'm pretty sure I'm just going to regret it, and in a couple hours of implementing it, I'm gonna have to split it anyway. So I get to eat my own words. Of course. It always ends up that way. So here's blizzard.cpp, and I'm just gonna paste this and remove what's unnecessary. So I pretty much just do the same thing, split up the definition and the implementation. Like so. That should be pretty much everything we'll need. So now Blizzard Snow emitter would be required in here, which is the problem we were running into earlier. We're just now seeing it here, is that if I included effect.h and then I included Blizzard Snow emitter, both require each other. And so it just got stuck. Now I'm separating them, so Blizzard no longer relies on it. The Blizzard header doesn't, so I won't include that, which is what I want. Oh, I still need that though. So include Blizzard Snow emitter. And then we go in here, and we're just doing the definition, the implementation, excuse me, of those. And this always gets a bit messy, of course. And let's see what we don't need. So first off, it'll be blizzard.h. Oh wait, this should be blizzard.cpp. Blizzard.h no longer exists. So it would be include effect.h. So let's get rid of blizzard.h. And then in here, we just need to include game, which means we have to include adventures in Listoria. Which shouldn't harm it because now it's in a source file. Okay. Java runtime requirements always kept me away from it. Same with C# and .NET. Yeah, that's very fair. The build systems for them get quite funky. For sure. It looks like now we have solved our header circular dependency issue. So yeah, when you're working on a larger project, the headers can quickly mesh into each other and cause loops and problems, so you have to be very careful. Usually, I've noticed every time I've tried to take a shortcut and inline everything, it never works out because of the way all these headers have to be included. So, funny enough, that's just how it always is. So, what is going on here? No appropriate default constructor available. Really? Default constructor? Oh, these are inline. Get rid of that. Accidentally writing inline there makes it so these weren't defined, or were already defined, so that should have been the issue, I think. I'm gonna move this down though. That should be visible. Well, actually that's not true. There's nothing there. Anything else? It's still complaining about that. Oh, it's complaining about no Blizzard Snow Emitter default constructor available. Really? I thought I included it. Maybe I messed up. Let's have a look. Blizzard Snow Emitter. Oh, because it wants to be default initialized. That's right. So we need to... we either throw it onto the heap, or we actually initialize it here, which we kind of can't, because it depends on some of the parameters here. So we do have to define a default constructor if we want to use it in this way, or put it on the heap. So what would a default constructor look like, and why would I need to create this later? I guess what I would have to do is... yeah, I think it's the only way. I'm just trying to think, can we avoid that? I feel like we can't, at least with the way we're trying to use it, right? Do we need to store it is the question. I guess we do need to store it, so yes, we're going to create a unique pointer here of a Blizzard Snow Emitter, and then we'll initialize it inside of here. Oh, it can't be const though. Well, actually it could. We just have to make unique inside of here. That's doable. It's a little messy, but it's doable. I've also never had to do it before, but it's funny. So we can define snow here as standard make unique Blizzard Snow Emitter. And here we define our position. our image file name. So we're just going to do circle.png for now. The radius, scale range. So this is where our parameters come in. So I think at this point we want to add that parameter into here as well. So let's do that. We're just gonna say range, scale range, somewhere in here. Const range, snow, scale, or size range, I guess. Do I need anything else? We also need the frequency and timer of the emitter we're creating. So it's going to be emitter frequency and emitter timer. Timer? Wait, isn't timer the lifetime? I guess how long you'll last. Yeah, so we already have the lifetime. It's the timer is going to be same as the lifetime. So for this, we have to provide the snow size range. And then we provide, what else? Hello? IntelliSense? Can you keep up, please? Oh. Now that I've changed this, I need to update the definition. Or, excuse me, the definition of it. So back here, add those two. Emitter frequency, I think that's it. Then we're back here, and it's going to be emitter frequency, followed by the timer. So our timer is actually our lifetime. And whether or not we're on the upper level. So that will instantiate the snow instance by creating a pointer out of it. Oh, I have to move, or I have to define that. And then in the update function, we have to run the emitter ourselves. So snow update, which is then going to update the emitter. And when this blizzard object gets destroyed, because the unique pointer is held inside the blizzard object, that's when the unique pointer to snow gets destroyed too. And this is the only place that snow is referenced, so naturally we won't run into any issues where somebody's storing a raw pointer of snow and tries to illegally call it at some point in the future after its lifetime has already expired. I see you have some function declarations with virtual and override. I'm not familiar with this usage. I always thought of it as virtual being the explicit request to create a virtual translation table so derived functions can override it, and override being that declaration of override. So would virtual override be the intent to make virtual an override itself? So virtual is completely optional here. It is very much an optional keyword. Its only purpose here, at least for me, is to say that this is indeed a virtual function. It's not just like something I created. So virtual is completely optional here. It doesn't serve any purpose. In fact, you can leave it out completely if you want to. The only time it matters is in your initial class. That's the only time it actually matters, right? Yeah, so it's purely visual. Same with override, actually. The only reason override is here is an indicator to... I think it actually is a hint to the compiler it's supposed to be overwritten. If you include override here, and then do not include a definition for update, I think it will complain. It'll say it needs to be overwritten, but let me double check. Well, I think if you just don't include it, it's just going to complain it doesn't exist, period. But I'm pretty sure override and virtual at this level is completely... is just for your own information. As in, we're overriding this function, this virtual function. In a sense of, also, if something... So if something inherits from collect coin effect, and collect coin effect is the parent, then yes, this virtual would actually have a use, right? But right now it doesn't. Additionally, including final is optional, but then it indicates to the compiler that I can't inherit this any further. So yeah, these get a little tricky. I know override is purely visual candy. Virtual can still be used to indicate, hey, this is going to be a parent to something else. Yeah. So yeah. It's very interesting. I like having discussions like that because there's a lot of times where these keywords are sometimes completely optional, and including them is just a hint to the programmer what is going on. Did I try building this? I think we're almost good now. I think we fixed everything that was problematic. So we call snow update, which is going to run the emitter. What I wanted to do is right at the start of this actually is run the emitter a couple times, just do like kind of a initial setup of the emitter to run maybe like 50 or 100 times. 100, just generate like 100 snow pieces right at the start, so that's not starting out with a blank slate. Just for the sake of the visual. So I'm going to do this from oops. Let's say 100 times. We're just going to run snow emit. So the emit function is what actually generates those particles. So I still have some undeclared identifiers. We'll address that in a minute. But yeah, calling emit will actually do the effect. So just run that 100 times. That there. Now let's look again at emitter. It's still an undeclared identifier. I should be able to do it now without it complaining because I've moved everything to the right places. At least that's my hope. I don't think I've messed up anything else. So let's try it now. Oh, you know what? I know what this is. This isn't because I can't include it. This is because emitter doesn't actually exist. I renamed it to iEmitter, and I guess I missed it in the refactor. Maybe there was an error out here and it couldn't modify this file at that time. But no, usually I use Visual Studio's built-in refactor tool. It's supposed to grab everything. I probably didn't check what it didn't hit, because sometimes it doesn't hit something. So that's my fault. Fair. Okay, it looks like we're done building, so that's good. I know someone wanted to see what my game looked like, so you finally get to see. Actually, that's a lie. Starting the game with default pack ID is not allowed. Let me go grab that real quick. So for context, for those that are new here, my game uses commercial assets, and those commercial assets require a... Where'd it go? Oh, my thing froze. Those commercial assets require a specific pack key to encrypt and unencrypt them. So I usually have to grab that. Obviously it's sensitive, so I can't show that. But if I ever have to reset my repo, then the key gets erased. Because it's an untracked file, so if at some point I have to git stash, then that also erases anything that was untracked in git, and that erases my pack ID, so then I have to restore it. So I just did that. And so now if we run the game, it will actually build properly. Well, not build properly, but run properly. It's just a runtime error I created, so lets me, the developer, know that the assets are not going to be encrypted. Okay. So this is what I was talking about earlier. We added a check to say, hey, if an ability doesn't exist, the game should error out because we have either typoed it, which is what I wanted to catch, or we just never created the ability. So in this case, it says that the Frost Mage wants to use the ability Freeze Ground, and it doesn't exist. So now I know that check works. I'm gonna go ahead and add it to the monster ability list. It doesn't actually do anything yet, but adding it just satisfies that check. And of course, we're gonna get back to that later today. Okay. Oh, I also realized I won't be able to see the blizzard yet because we need to, 1, add the Frost Mage into the game, and 2, or into the level, and 2, make it actually cast it right. Cannot find monster type Skeleton Fire Mage. Did I delete it by accident? Oh, I did. Oops. Okay. How about this? I will copy this, and then I'm going to undo all changes in this file. Because I essentially copy and deleted the previous entry, and then overwrote it. So it's like I didn't change anything. Except it just renamed it to Frost Mage with some stat changes. So right below it, we had Skeleton Frost Mage. Cool. So the next thing we're going to do is we'll go back to GIMP. In our monster tile set, let's add in an entry for the Skeleton Frost Mage. We'll just use its temporary sprite. Then we go to our monster presets, and we're going to make a new template for it. Skeleton Frost Mage. Class is monster. And go ahead and save that as a template. And then go to our stage that we're testing on. Remove the Fire Mage and add in the Frost Mage. Set the spawner appropriately. And then it should be able to technically cast both abilities now. So I'm going to make it so the Frost ability actually casts the Frost effect. And maybe even do the damage. Hopefully, like, that it just works. Because it's an effect, it should render the correct stuff as well. So for Blizzard, let's do this again. So we have access to the... So what I was thinking, because I noticed I'm doing this over and over, I'm realizing that I need more data being passed in here than I'm originally giving it credit for. So I think what I'm gonna do is convert this lambda to pass in more stuff. I think that would be better. If we pass in both of these, then the config parameters will be available by default, because right now I have to add these in for this macro to work because it assumes there's a variable called M, which is a reference to a monster, and strategy, which is a string containing the name of the strategy that the monster is currently running. So these two values can be pulled if we did that. Furthermore, I was thinking about it. I'm like, why do we have to specify the strategy if we know the strategy via the get strategy name parameter function? Why do I do that? I've always wondered that, and I'm not entirely sure why I do that. I feel like it's just from an old... It's again one of those tech debt things where originally I designed it and then I realized, oh, I should just make it accessible directly. So this is something I think we might want to address today. It would be a pretty big change because it affects literally all the AI code. But it might be an interesting thing to pursue here. We've got a good hour of programming left for today. So maybe we'll go do that. That'll be a fun little side thing. Because I feel like this is very annoying to use. Both here right now and this thing that I keep having to revisit again and again. The same problem. So that's telling me we have some pain points in our code base that we're working on, and we should address it. I think it's pretty important we address it now because we still have a lot of monsters to develop, and if this keeps coming up, it's just going to be annoying to deal with for the next 20 or 30 more times. So pain points in our code base I think deserve looking into and at least considering a refactor for. So before we continue and actually do anything about our blizzard, let's address this at least. So right now, the problem is I am doing these two lines of code over and over. Simple enough, we can move these into parameters that are passed in through here, because this information is known every single time. So, to make that work, we're going to go back to the original call that occurs in monster.cpp when a monster casts an ability. So right here, under cast ability, or excuse me, perform spell, when we cast the spell, it's going to look up the spell from the spell function table and pass in these parameters right here. So we would like to change the parameter list to suggest something else. So instead, let's pass in a reference to the object itself. This will be M. So we're going to dereference our this pointer as one argument. And then the second argument will be the strategy name itself. Even though I think we're about to address the strategy, we're going to do get strategy name for now. But I think we're going to address this in a second as well. But this is just to make it compatible on this level. So now we're going to go to the header and redefine what value or what arguments the lambda accepts. And instead of doing caster monster as a weak pointer to a monster, now just accept a monster reference. And then additionally, we want to now accept a strategy name. So that's going to be a standard string reference. We're using strategy name equals, we'll do const standard string reference. And that will be right here. So with that set up, we now have 4 parameters being passed in. Expected a type specifier. That's kind of strange. I feel like that should be good. It's type specifier. Also, why do we have string view? Oh, I see. That's the key for the map itself. I feel like the compiler just hasn't caught up, because that's fine. So, or the IntelliSense, excuse me. So now we go back to the CPP file. Instead of doing this, now the last item is a strategy name, and then we have all this information here. We just have to modify what's coming out of it. So instead of monster now, this is just going to be M, so we don't have to do the cast to a weak pointer. And then for strategy name, it's just going to take on the name strategy, which means that macro is now satisfied for both of these. Which means we don't have to include these 2 lines anymore. And that saves us some typing and also looks better. And functionally, it's exactly the same code. But that brings me to another point. Why, in our macros, do we have to define the strategy when the strategy is known by providing the monster reference already? That to me just seems like it's old style, old tech debt. So maybe we want to refactor this now. But before we get into that, let's go ahead and first make sure this builds. And if this builds, let's commit before we make this change, because this is going to be a very, very large sweeping change to the code base. So strategy name, standard string differs in levels of indirection from const standard string reference. Ooh, we have strategy name somewhere else. That's interesting. And it's standard string. Okay, so I think I see what I'm going for here. Instead of defining what the modifiers are in the using, I should instead provide the modifiers in here as if it was an actual type. Like, providing the modifiers up there doesn't really make sense, right? Because it's like I'm squeezing in more data than I should. So I think this makes more sense, which means strategy name is being redefined when it doesn't have to be. And then we can go over here and just change this to reflect that. So this is now a reference to a monster class, and this is a const reference to a strategy name. And then we can rename all these like so. Okay, and now it should be happy. Still failed. Strategy name is an undeclared identifier from this file. Funny enough. So we still have to provide a using here. However, using strategy name in here is defined. So that's interesting. Where should it go? I feel like this should be in monster strategy helpers. That would make the most sense. Because monster strategy helpers is where, well, the monster strategy idea even gets formed. So I think this goes in here, and then this includes that. Include monster strategy helpers. Like so. And then once again in monster now it's undefined, which is fine. We'll provide that again. Include monster strategy helpers. Hopefully we haven't started like a circular header dependency. I don't think we have. At least I hope not, because all this uses monster attribute, which is a bunch of enums. And it depends on string, so I think we're good there. So far it's building. Excellent. And what my idea is we're going to commit all of these changes, and then we're going to look at fixing the entire way we do configs, in the sense of, okay, for the strategy name, it's already included in that monster reference we provide. Why do we have to provide the strategy name again? Doesn't really make sense, right? Because the strategy name is always just going to be the strategy of the monster. Equally, the strategy being provided never really changes. At least, I don't think it does. There are some monsters that use multiple strategies, but for those monsters, the strategy name that's always passed is the same strategy the monster initially started with. Let me give you a good example. Inside of the Wolf AI, the Wolf AI uses a couple different strategies, but this is essentially the Wolf strategy. So naturally, you'd expect the strategy name to always be Wolf. Well, when it calls the Run Towards strategy, you can see we actually specify the name of Run Towards. So does that mean, does this actually matter? Does this matter? Does this mean it will reference variables from the wrong strategy when it switches to calling a different strategy? But what is get strategy name then? Right? Get strategy name has to be the original strategy name. So is this the reason why I don't do that? And if that's the case, then we have another way we can deal with that. Or I can handle that. If we look in the monster strategy class, under the implementation of it, it's under the monster class itself. Let me scroll down here. Is it in here? No. Where is it? It's in run_strategy. At least it should be. Here it is. So, this map right here contains the names of all the classes tied to a strategy function. So let's say I call the Skeleton Barbarian, it should know it's called Skeleton Barbarian. Why do we have to like double up on the data by typing it manually ourselves, right? So maybe we need a reverse lookup table where this strategy knows about this and vice versa. Maybe that's what we have to do. Very interesting. Okay. So maybe a reverse data lookup table is necessary for this. So initially what we do is we just insert a string to strategy data. So what if we turn these into macros where we also go into these? Well, but these aren't objects, right? These are functions. So how would that work? The only way I could really think of this is to make a like strategy name lookup table, right? So we would provide another global or something similar, or maybe a static, right? I think a static would make more sense here. That just has the strategy name. So it could be under the strategy struct. I think that's fair. Put it under a namespace, right? And just call it the static standard unordered map of these functions. So I don't know if you can serialize these. I guess that's the big question. Can we serialize these? Because if we can't, we might have to do something else. I don't think you can serialize these. Like, these won't work as keys in a map. I'm pretty sure you can't do that. But who knows? There's always a first for everything, right? Let's try it anyways and see if it complains. I highly doubt you can do this. Let's actually try this in a small example project first, because I don't want to type out all this and then realize it doesn't work, right? That's kind of dumb. So we're going into our test project. It will replicate pretty much the same idea, where we're going to have a new unordered map of a standard function. We'll make the function pretty basic. Let's just say it's got 2 integers in it, whatever it does, and it produces a string, right? Like, I highly doubt this is a thing. So there's our test map. Also, this is not how you do this. It should be void int. Okay, so it hasn't complained so far, but let's just try to compile it. So it failed. Attempting to reference a deleted function. Hash does not exist for this function. I think that's very fair. I don't think it makes any logical sense that this would even be a thing, right? So we have to think of some other way to do this. Essentially, what we want to make is some kind of class that holds 2 pieces of data. It holds the string to a strategy and the strategy function itself. It needs to tie these 2 pieces of data together. They can still be accessed via a map that has the strategy name tied to it. But then inside is another class that can serialize as, or hash out as a string. I think that would be fair. That's one way we could do it anyway. But I have to use something as a hash that matches this. Another way to do it is to turn this into something like an enum. The enums would reference numbers. The numbers would index into like an array, and the array and maps would be linked together. that way. That is another way to do it. Either way, we do have to do some major restructuring of how we handle this because we can't hash functions. The way we do this clearly will not work. So, what do we want to do? Put this into a vector? And then number these off? That might be a way to do it. And we can abstract that, of course. If we make a macro that just counts up a global variable here, it can just count up, and so we don't have to think about the index number. We just see it as use this. So we really don't have to think much about it. Everything that happens internally can happen on its own. So I think that's the plan. Put these into a vector, and then the strategy data will contain the name of the strategy and an index into that vector. I think this is the way to go. Alright, so we'll keep it secret for now, like hidden. So while this is, yes, a struct, we want to make it private in this case. We don't want the vector to be known. Like, we might as well make it so as if it doesn't exist. We can just access it like we always would. So we're going to say standard vector, and we're going to provide all the functions inside of there. So for now, strategy data uses functions with this setup. So for this setup, are we changing it? That's the next question. Are we changing the definition of this function so it doesn't have that string anymore? Because we realize the string is redundant, right? So while we're at the same time while we're doing this, oh, before we do any of this, I'm dumb. Let's commit real quick. I almost forgot that the whole point of this was we're about to make a massive change. Let's make sure we commit everything first before we proceed. Did I make anything change? Okay, I added private. That's like right before we start, right? So I'm going to stage all these changes except for that one. This is Blizzard particle effects plus spells, spellcasting preparation, and implementation. Also added skeleton frost mage. This is release build 12481. Okay, so that's that. Okay, so my next thing to do is actually do this. So now we can actually work on this and keep it isolated. It's in its own commit. So I think we're getting rid of this. We have decided this is redundant and unnecessary for this right here, which means all of these are probably going to change too, because now they're not going to reference that. So these are going to go away. We can see here all of these are we're going to delete all the strategies from them. So I'm going to highlight all these. We're replacing in selection standard string space strategy, comma, with nothing. It should delete, or wait, let's do it the other way. That way it gets all these guys. That looks good to me. So because we've done that, that's going to make it so we have to go into every strategy and now modify it to not include those, which we'll get to in a minute. Let's implement the core of this new idea first. So right here is going to be the vector for all of the functions. So strategies is what I'm going to call this. And then in here, under strategy data, it's no longer going to be an index to those functions, or it's not going to have a map to those functions. It's literally just going to have an index into there. So strategy index is what I'm calling it. And I'm going to make the strategy index be in... Because we're going to need this if we ever need to access strategy data. I think it makes sense to put in here. But I could also put in monster.h because that's actually more related to it. In case I needed it again, right? Yeah, that makes more sense. When it comes to the usings, it can be a little harder to decide where it goes because you have to really think about what's actually going to call this. So strategy index, I think, will go in the monster header because it's related to a monster as well. So using strategy index is going to be a size T. So back over here. Now this would mean we'd have to include monster in here for it to work. Would that be an issue? Because a lot of times, like monster includes defines, defines includes monster. Now you got a circular dependency. Does this one using get put in its own place, or do we define it twice? I think defining it twice is okay. The compiler will only complain if we change what the definition is. Like that one time we did. So I think we're okay there. Then we go back here and we say, alright, now that we have our strategies and we have our strategy indexing into those, we need to write a macro instead that's going to handle adding these ourselves. So we don't have to write or think about it. It'll just abstract, right? I think that's the best way to handle that. So let's make a new macro. Define add a strategy. And in this macro, it's going to be strategy data.insert, the first argument. So this is going to be the name of the strategy, followed by the index. Or no, followed by the function. The function will still be part of this. It's just we're going to add it to the vector. So provide the strategy function, and then do two things. First, do strategy data.insert, and this will give you a pair to a string, or it includes the map iterator and a boolean of whether it got added or not. So what's interesting here is we could actually write a check that will say whether or not it actually got added. If it didn't get added, then we know something went wrong, right? Although it's a map, so we should expect that it doesn't already exist. If it does, we could error handle it and actually kill it, saying that this should not have happened. But it should always add it. I think that's just a side effect of it being the return value of a map. But yes, the first thing we're going to do is insert it in there with the name, followed by an index into the strategy function. So whatever the strategy's vector size currently is what's going to be used. So it should be monster, strategy, all caps, strategies. And it's going to be the size. That's what's going to be the index, because we haven't added it yet. So whatever the current size is, that's actually the index that's about to be inserted into. So next, I think you use a backslash to continue adding to macros. No? How do we multi-line macro? I think we do that inside of a, like, in defines, we definitely do it. Oh, you just backslash at the end of the line to continue adding to it. So this is going to be a multi-line macro. One thing I do like to do is start it on a new line even to begin with, just because it looks a little cleaner. So the next step is insert into the array. So monster strategy strategies dot and place back the strategy function. And we could even go one step further. How about instead of adding all these words, we just include the name at the end? Right? I think that's very fair, and I think it's very doable. So we could say strategy function suffix. And that would take care of that. So that inserts it into the vector. So I think our final check is just if it already existed in strategy data, let's error out. So if strategy data dot contains the same name already, we're gonna error out because that should never be a thing. Then we call error followed by whatever, right? We say warning. We could do a standard format here. And actually, we don't even have to standard format because it's a macro. It will auto parse it. Wait, that's not true because then we have to do string concatenation. I don't really want to do that inside of a macro, honestly. It's kind of ugly. So yeah. But we say warning. Strategy named whatever already exists. This is not allowed. And then just put name there. Now we should never be allowed to add multiples. So that should be good. And there's our macro. So we can try to use these as our macro now. So the way we're going to do this is all of these lines are going to be replaced with add underscore strategy. And then at the end here, instead of doing this now, you're going to get rid of this. And then all of these should be fulfilled appropriately. We can look at how one expands just to see if it ends up correct. So let me just expand inline and see how that looks. So this is how it would look. So safe map has no member contains. Now that's interesting. This is a safe map, which is my own custom map structure that prevents us from adding more things in the future once we lock it. So let me go to strategy data real quick, or not strategy data. Let me go inside our safe map class implementation and let me implement contains real quick. I think this is a really important function to have. I'm surprised I haven't needed it up to this point. We've also got a safe unordered map. So let's implement the function for both, right? So auto contains auto name, auto key, and return contains for the inner map. So map dot contains key. It should really be that simple. And the same goes for the other function here. It also should not modify anything, so it should be const, I would presume. That contains is const. Right? Yeah, contains is const, as it won't modify anything within its class. So now we go back here. Contains is implemented. It's just strategies is inaccessible to the run strat or the monster class. So we have to at least allow that. So we're gonna go here and we're gonna say inside of struct strategy, friend class monster. And that should mean monster is now able to access it. A non-static member reference must be relative to a specific object. Is that not static? Okay. Make it static. There we go. And our macro now works, as we can see. So from the perspective of this file, we can undo. And that's our new macro. So So far so good. No problems there. The next thing to do is work on stuff on this side. Now that we have this, we have to go through all of these and modify them with its new constructor or its new function. So basically we're getting rid of all of these. So what I could do is I could do a global find and replace and look for these, and we will see what happens. I'm going to do a proper search by finding them all because we want to make sure we're not editing something very important. So I hit find all here, and we can just take a look at what it's referencing. It looks like every single one is only pointing to a monster strategy file. So because of that, we know we can safely run a find and replace on this completely. So we're going to find and replace this string with this string. So replace all. It should be 40 something. So 40 occurrences replaced. Good. So that takes care of that. Now we have to address these macros because they don't have strategy anymore. So right now they're confused. So instead what we're going to do is get rid of the strategy parameters here. And these guys. Okay, and then the next step is to go in. Now that these are gone, these are okay, but they don't work because these functions don't actually return anything correctly now, because they originally required the initial strategy. So now we have to go through and modify these with that correct strategy. Now, originally when we passed in a different, like, let's go back to the wolf example, right? So let's talk about what would happen when we normally pass in this here. So now it's assuming that it's going to use the run towards variables, not the wolf strategy variables. So whatever is passed in here has to know that this is run towards. So again, this is where the reverse lookup comes in, because now how do we know that this function is what it is? Like, how do we know run towards is run towards and it's not something else? Well, this is where we instead have that reverse lookup with a hash, because we need to find out which of these functions maps to here. So we have to do another data structure that links these two together. And this is the part that's kind of like obscure and weird about all this, is that we have to add in a way to connect these together. So we're going to be making some kind of new struct that has both of these combined, so it's not just a standard function here, but it's actually a standard string and a standard function. And then from there we have to make either a map, or we have to use like a standard find, right? If we had like a standard find, then that might work. Like, I don't mind doing standard find. I think it's kind of weird, but it could work as well. And from what I heard, unless you have something really, I guess, small or large, I don't think map actually outspeeds a standard like vector lookup. Like, I think it's actually pretty much the same thing in terms of raw speed. So that's something to consider too. Yeah, it's just what we're about to do here is quite complicated and is kind of the meat of when you're designing your program, what you have to think about, because these data structures and how you link them together and design them, Like, this is literally software architecture. It's like, you have to decide what data structures you want to provide such that your program has access to the data it needs to, and everything connects together. You can make this super complex, or you can just provide the wrong information, and then nothing connects the way it needs to. This is literally software architecture in a nutshell. And designing it can be very tough. You can easily make mistakes. You might not even make it in a good way. It might be too complex. You might have to redesign it. This is definitely the hard part. So yeah, I think the plan is we make a struct that has both a string and a function tied together. Whenever we have to find out what the strategy index is, we will iterate through this and look it up. That way we know what we are when we execute our strategy. Like, we know what our name is. That's essentially what we want to provide, is what is our name when we're running. And that makes me wonder, like, do we still want the strategy name to begin with, or not? The strategy name has to be looked up every time. It can be cached inside that function, of course, but it has to exist, right? So are we making something that caches that every time, or are we looking it up every time? Will the compiler optimize and cache it for us? Maybe it will. Maybe it won't. There's a lot to think about. I think we lose some speed here, but in turn we get a much more sensible design out of our program, which I think is the most important part. If I'm being completely honest, that is what we're trying to do here, is make the design much simpler to work with, more painless. So I think it's worth it to do this in the first place. Alright, so I think we after talking about it out loud a bit, I think I have a plan of attack. So let's try to implement it. So this is a struct, and that I'm calling the strategy struct. It's a little confusing because I have a capital strategy class, which is really just a namespace at this point, holding a bunch of information. In fact, I would dare say if all of this is static right here, would it make more sense to turn this into a namespace? It essentially is being used like a namespace, and it works like a namespace. There's nothing in here that requires it to be a struct, right? Everything in here is public? Well, not necessarily. The strategies vector is not public. So the only feature we're getting out of using a struct right now is privatizing this value. So I guess we could keep it that way. I don't think I mind that too much. But yeah, the struct strategy is going to contain both the strategy name, which I will use here, and the function itself. So that is the strategy function. Strategy func. Okay, so now that we have that, and honestly I would probably make a using for this too, because I think that just makes sense. Let's make a using for both. Using strategy function is this. Just saves us some typing. Strategy function. Strategy func. So just like that. Oh. There we go. Okay, now we're back down here and we're doing a standard vector strategy now that contains both a name and a strategy function linked together, like so. So our next step now is whenever we have to provide the name, like we want to know what the name of this strategy is, we just do a function called getStrategyName. And I think it would make sense to include that inside of Monster Strategy. right? Just get strategy name and we implement that. And we only need that inside of the get config functions. So maybe we don't even implement that here, because where are those? Let's go look. So whenever we do config float, where are these called? Monster strategy. Okay, so it makes sense that goes in monster strategy, right? I think so. So we're now going to make inside of strategy, maybe we make it a global? Strategy. It's a little wordy, I know, but I think it makes sense to like segregate it kind of. So we're gonna make a new static const standard string reference. Is this a good opportunity to string view by chance? This would be a good opportunity to change it to string views. It's not a bad idea, but if we have any place where we need the strategy name normally, then that conversion would cost us. So let me think about that. Do we need any conversions? When do we use the strategy name? We use it in a couple places to compare. Why are we comparing? We're comparing with strings, and string view comparisons and string comparisons are free. So my thinking right now is going towards turning strategy name into a string view to save us a little bit. It's also a more modern approach. I don't see the downside to using a string view right now. If we run into trouble with it, then we will address it then. But right now, there's nothing that we need string view for. So I think we're okay. So back over here, I see we're using, for name, we're currently using strings. No member strategies. It should still have strategies. Oh, we're just not done here. But yes, I'm thinking we just provide a string view of get strategy name. And this is going to be internal to wherever we're currently located. So how are we going to pass that in? Because what we're gonna need to do now is somehow say, okay, pass in this function, and this function, I guess it will be a pointer, right? So we're adding the strategy into a vector. We're calling it, we're gonna call it from the vector itself. Like, this is stored somewhere. So these functions will be added to vector as strategy functions. So they will be accessible via pointer. Is that what we're going to use? We're going to compare pointers? I feel like that's the only way, comparing function pointers, that we're going to get anywhere with this. Because yeah, how else are you gonna look it up? How else are you gonna know, oh, this is what its name is? You have to reference it by pointer then. Like, is this pointer for this function we're currently running the same? And even then, it doesn't know, right? Like, we're inside the run towards function. How is it gonna know it's run towards? It doesn't. It actually doesn't. So we have to think of another way to connect it. It's like, okay, let's say we are a slime monster. The slime monster has a strategy, uses the run towards strategy. So that's how we can send in the initial name. We say, okay, you're the run towards function. But what happens when it calls shoot afar? How does the shoot afar function knows what it is? I think the only way, the reason why we've had trouble for so long is that these aren't actually classes. If these were classes with their own, like, executable functions, then these would have their own instance in memory instead of just being functions passed along. Because the only way to do this right now is to hard code them. We would hard code them and say, okay, this is what your name is, and it's going to be that every single time. So are we just going in circles here and realizing that we can't actually change this? Or do we just fix the config parameters a little bit to respect these? That's the real question. It's like every time I call run towards, the run towards function should know that it is that strategy. I think I'm starting to get onto something. What if when we are calling run strategy, it figures out what its function pointer is and passes that in as the string at that moment. So it always knows and we don't have to do it ourselves, right? I think that's the play. I'm starting to see it now. Okay, so what we're going to do here, let's undo, clean slate. We can do that very easily in Git, right? So we just undid everything we just did. And that's fine. That happens when you're doing software architecture. Maybe the first time you do it, you don't really quite make what you need, right? We realize that these functions still need their strategy variables, but these strategy variables are going to be hard-coded. As in, they're going to be hard-coded when they are called. So the key actually is to first go into the run strategy function here, and you see here, the initial strategy is passed in. This is the key. Because from now on, once this is passed in, every other call is going to use that too, or is going to use a different call. So I think what we need to do is we need to hook up run strategy with another function, and then if we want to run one of these other functions, we call run strategy again with that function instead. I think this is the key to resolving this, and is something that I might not have realized until now. But yeah, that is what we have to do. I'm just trying to think, are these, if these functions are built into here, are they mapped to pointers? Like, is this function being called and the mapped function being called two different functions? Am I just creating two functions for no reason? Like, is that what I'm doing? I feel like that's what I'm doing, because right now I'm copying them into a map. That's a really fascinating thought, is that I'm creating the functions here, and then I'm copying them into something else? Isn't that fancy? That's kind of weird. But yeah, I think doing run strategy is the key, and then calling these functions elsewhere is the other key. Like, we have to, I think, privatize these. These shouldn't be accessible to any other strategy call. Like, what happens, let's just test this theory, if I private these? I think if I private these, then let's go into like run towards, right? Or maybe Wolf was the example we were using earlier. Can I now access them from other classes? It looks like I still can because it's just the same class. Which is not quite what I wanted. So my idea is that we prevent us from calling this directly, and we have to call it some other way. I'm just trying to think how. Because right now, manually putting in that name is not what I want to do. Maybe we turn it into macro. I'm not exactly sure. There's a lot of ways to go about this. All I really want to do is eliminate that config strategy parameter, because that extra parameter I feel like should be unnecessary. You're so smart. Meanwhile, me struggling for my DSA exam. Is that a computer course? Is that data structures and algorithms? That's what it looks like. I'm not sure. Oh, cool. Well, I wish you good luck with that. Hopefully you do well. So yeah, the key is trying to get rid of these. But to get rid of these, we have to know what the strategy name is going into that. And to know that, we originally passed in this parameter. How can we pass in this parameter without needing to know it right off the bat? We have our lookup table of functions to names, but how do we supply that within our functions themselves? Because I'm pretty sure, at least my running theory is that if I do a lookup, if I say, okay, does strategy data, which is the structure that holds all the function pointers, I have to include it. Would that have the same function pointer as being held in here? Because if it does, I think that makes it easier. So I'm gonna say if strategy data dot contains, well, there is no contains because that's a safe map and I implemented that in my changes, so I have to re-implement that. But it would be like if strategy data dot contains our pointer, so I would say the pointer to our own function. Like, this function isn't aware of itself, which I think is the biggest problem, is that we need to, like, override a class that has the function in it and the string name in it, so we can connect everything together. I think up till now, using a function for all these was the wrong move, because we can't connect this data together. That's what a class is for, right? To connect multiple pieces of data together. So I think we went wrong by initially making these all functions, and I think it's finally time to address this in a rather cutthroat way, I guess is the way I would describe it. This is literally the cutthroat version of fixing this code. So run strategy needs to call classes of strategy functions, I think is the way we're doing this. So let's make a new struct called a strategy function, and from here the strategy function is going to contain both its base function and the name of the strategy itself. So name of strategy and a function containing all this stuff. This is going to fix everything, because now if we ever want to call the strategy, it'll be the name and the function will be tied together, which is exactly what we've been trying to aim for. These can't just be standalone functions anymore. They are missing all of the features that an object would have, which is what we need right now. We need all the features of an object. So finally addressing this, I feel like this is something that needed to happen long time ago. Where was I for the map editing? Okay. Not here. Here. Okay. So yes, strategy data. We need this guy again passed into here. But instead, we're not going to include the string because the string was already included. The string needs to be an outside data source. And this is just the strategy function itself. I'm just going to call it function. I think call it strategy function at this point is a bit redundant. So now we have to turn all of these into static or strategy function classes. I think they can remain static for now. I don't think that's the issue. But they definitely cannot be just actual functions anymore. So we're gonna turn it into this. So with this, I don't think we have to supply much. We just supply the name And of course we supply the function themselves. Now the functions themselves, I think the reason why I wanted to do this originally was the idea was to write each AI in its own source file. So that's why I originally did this, because if we look at any source file of any AI, like the wolf, we can see I just have a separate file for that, and that was nice. I still would like to have that. I don't think that's a bad thing, but we need to be able to change how we operate that, because this isn't going to work anymore. So the question now becomes, do we actually have functions called this, and then we have strategy functions inside of here that will then reference those to create strategy functions themselves, which would just be strategy function, standard function. See, I was thinking about this. I'm like, shouldn't they just be pointers? Why are we copying the function? I think they should be function pointers. Unless standard function is a function pointer. Now I need to look that up. Internally, what is standard function? I don't think we've ever researched that. But I think it's just a pointer to a function. Which means getting the pointer to it is redundant. Standard function is a general purpose polymorphic function wrapper. Instances of standard function can store, copy, and invoke a copy constructible callable target. Functions via pointers thereto. So that tells us they are pointers, as well as pointers to member functions and pointers to data members. Okay. So that's what I wanted to know. They essentially are pointers themselves. So we're never copying data by doing this. I don't think it would make sense to be able to copy like the instructions into another place, because that would make the instructions have to reference different addresses, and like that to me sounds super crazy. So I think it makes sense that these would be function pointers anyways. So yeah, this is just a wrapper for a function pointer. So that's fine. But yeah, essentially we're gonna have a ton of these, but I think these are actually gonna be defined inside of a map that just has strategy function, or name, comma, strategy function. So I think that's the next step, is strategy data is standard string, comma, these strategy functions. Because now they can turn into being like, kind of like lookups themselves. Although really I want them to be vectors. I really don't want to use a map, but maybe I do. Because I want to be able to look them up the other way, which means a vector would be more ideal. So I think that's what we're transitioning to. We're turning this to be a standard vector containing the strategy function data structure. And the strategy function data structure is going to allow us to look up the names via iterating through it and finding a matching struct. So I think that makes sense. So now, when we look back at our monster strategy definition originally, inside of monster strategy, or run strategy, excuse me, run underscore strategy. So instead of doing this, it would become and place back with an object, or well, a string followed by, right? Because it would be the name followed by the function. So that actually works. That's valid, I think. Assuming strategy data does what I think it does. It's just undefined here, which means we could bring this, well, strategy function, oh, is inside the strategy struct. So it would be monster : strategy : strategy function, like so. I think this would actually work. Like, I don't think compiler complains about this. I just want to try building it just to see, because I'm very curious. Yeah, we're gonna get a lot of errors, but that's okay. I'm more interested in the specific line I just wrote. It looks like it will work. I don't think it'll have a problem with that. So it's complaining on line 49. I'm seeing if it complains on the line I just edited. This is line... Where's the line number? Oh, right there. So this is line 48. So any errors referring to 48 would be of interest to us. 48. So I'm seeing 48 here. But that's in skeleton captain.cpp. I'm only interested in the run strategy file. So let me see if that has any problems. Let's filter by run strategy. Okay. So errors in 49 through 89, but not line 48. So line 48 successfully compiles. So I think this is what we're going for. So while we haven't implemented it today, like we don't have time to finish it today, this is what we're aiming for. So we're gonna work on this tomorrow. We're gonna refactor all of these to now be placed in this new data structure of string to strategy functions. We're moving all these to be objects. And then when we call run strategy and this function is called, it's going to pass in the strategy name to this. It's going to call the correct static function with the correct strategy name. And if we ever have to look it up to call another strategy function, we would do so via this. But I think we need to enforce call strategy and hide these. These need to be hidden. So that's the next step, is we can't have these be accessible inside of monster strategy. So they need to go somewhere else, someplace private. If they're in the same struct, they will be accessible. I think if I hide them in another struct that's private, then they won't be accessible. So that's what I want to look at real quick, is putting them in another struct. Does it hide them? And we can call these like specific strategies. So let's see if they're hidden now. We'll go back to Wolf. So it says run towards is undefined, but can we access it if we do specific strategies? Specific strategies. : run towards. So it doesn't know this exists. But at the same time, this doesn't exist now because it is in... So no matter where I move this, these are gonna know about each other. So I have to transition these into being functions that are defined elsewhere. So it's like these... when I create these classes, they have to be created in such a way that they are in their own separate files to be created. I'm trying to think how I would accomplish that. One way I could do it, this is kind of weird, is I could just write it as a separate source file, standalone, and then include it later. Would that be weird? I feel like that would be weird. But it might actually work. Like, for example, instead of writing this, I would write... So I'll do something like include strategy data. And then I would do strategy data and place back. And I would do, in this case, it would be wolf, comma, and then I would include a lambda function like so. In theory, this is what I would do, but this is just raw code exposed out in the middle of nowhere, right? So we wouldn't get any like IntelliSense, which is I think my biggest concern here, is I would like to have IntelliSense activated. So unfortunately, I don't think this is the play. So I'm starting to think, okay, we could do separate like libraries, like we could have compiled linked libraries for each AI and have them access an API, but I don't know if I like that. Because technically we do have a DLL of the entire Adventures in Lestoria game. Like that does get compiled, it's just I don't use it except for unit testing. So I don't know if I want to do it that way. There's a lot of ideas floating here, but this all needs to be redone somehow. I'm just trying to avoid the whole writing the function writing all the AIs inside one file. How can I avoid that? What can I do to prevent it? Because I liked this idea, but I think the way I implemented it is not quite what I want. Another idea is we just have these as like, they literally just exist. And then inside of here, we would do the actual strategy data and place back. Maybe we'd write a macro, and this would be our special way of adding our strategies to the game. So we would just call these functions once to add these strategies, and then from then on, the strategies would be added themselves. Okay, I like that idea. That might work. So next time what we will do is we will convert all these to just be functions that run at the beginning of the game once, and they implement all of these. They like create these runnable functions that have what is necessary to run monster AIs. I kind of like that idea, and I think it's gonna be the only way I can make this work sensibly and accomplish what I want, which is to get rid of this string strategy here, with us knowing that we know what the strategy is supposed to be. I think that's the play. I really think that's the play. It's gonna look something like this. You call all of these once, they add in all these functions, then you call these functions from now on, they're linked to a string, and it makes it easy for us to then call other functions. So how would I call something like this? I would have to make a function like, I'd probably call it like monster strategy run. I guess this is where I could also call like run strategy, and I would call run towards or something. Like this is ideally what we're getting to. We want to be able to do something like this and no longer have to do something crazy like specify the strategy in every single function and specify the strategy going into these. Like, we're trying to remove that completely. So I think we're almost there and we're on the right track. I'm gonna leave everything as is for today, and tomorrow we can begin writing it all. I think we finally have the big picture, and it's just writing the code. But we're out of time for today, so for those of you that tuned in for today, thanks for watching. I hope you enjoyed. It's gonna be one more sidetrack to make the code base even easier to work with tomorrow. And I think we'll be back on track to finish all these monster abilities. And yeah, it's been fun. I hope you all enjoyed. This is, programming's fun. Yeah. Till next time, take care everybody. Bye-bye.